Hello and welcome to Noah Chronicles, where we delve into the mysteries of the universe. From the origins of the cosmos to the nature of time, the universe is full of mysteries that continue to intrigue and captivate scientists and the general public alike. Join us as we explore some of the most profound and fascinating questions in astrophysics and delve into the unknown depths of our universe. Dark matter is a type of matter that scientists believe makes up a significant portion of the universe, yet it cannot be directly observed or detected with current technology. Its presence is inferred from gravitational effects on visible matter. Essentially, scientists can observe the effects of dark matter on other objects in space, but they cannot see the dark matter itself. This makes studying dark matter one of the biggest mysteries in astrophysics. To understand why dark matter is so important, we need to understand how gravity works.
We look in the universe and we see the effects of gravity, and let's add up all the stars and galaxies and planets and comets and black holes, everything we know about, to account for this gravity that we see. And when you add in the dark matter, this extra gravity, it turns the universe into the universe that we see. That's why we know the dark matter is real. We don't know what it is, but we know it's there because we can't make the universe as we see it unless we put this extra gravity into our simulations to match the gravity that we see.
Gravity is the force that holds everything in the universe together, from the smallest particles to the largest galaxies. However, based on the laws of gravity, there should not be enough visible matter in the universe to account for the gravitational effects that we observe. This is where dark matter comes in. Scientists believe that dark matter provides the missing mass that explains the gravitational forces that we observe. Despite its importance, dark matter remains a mystery. Scientists are still trying to understand what dark matter is made of and how it interacts with other matter. Some theories suggest that dark matter could be made up of undiscovered particles, while others suggest that it could be an exotic form of matter that doesn't interact with light or other types of matter in the same way that we are familiar with.
Particle physicists are convinced that it might be an exotic particle that doesn't interact with us, doesn't interact with our light, with our telescopes, but that it has gravity. So these particles are doing their own thing, invisible to us, but otherwise attracting our matter into nucleating us among them.
Dark energy is a mysterious force that is thought to be causing the accelerating expansion of the universe. Scientists still do not understand what this energy is, where it comes from, or why it exists.
Some mysterious pressure in the vacuum of space acting opposite the force of gravity. Whatever it is, we call it dark energy. That's our placeholder term to describe what we observe, the acceleration of the universe. Nothing known will stop this. So there's been some concern that maybe space does not have the flexibility necessary to allow such rapid expansion. And might space tear in some way previously unimagined? And what does that even mean? Does the question even have validity?
In fact, dark energy is one of the greatest mysteries of modern astrophysics. To understand the concept of dark energy, we need to understand a bit about the history of the universe. Scientists believe that the universe began with the Big Bang, a massive explosion that created the universe as we know it. After the Big Bang, the universe began to expand, and scientists expected that this expansion would eventually slow down and perhaps even stop. However, in the late 1990s, scientists discovered that the universe's expansion was actually accelerating, and this acceleration is thought to be caused by dark energy. Despite decades of research, scientists still do not know what dark energy is or how it works. Some theories suggest that dark energy is related to the vacuum of space itself, while others suggest that it could be a form of energy that is inherent in the fabric of the universe. Regardless of its origins, dark energy remains one of the most intriguing and mysterious forces in the universe.
In science, in astrophysics in particular, you have the capacity to measure something, even if you don't know what it is. For example, you could measure the fact that something is falling to the ground, but not know what it is or what's causing it or why. But you can measure it. You can measure the sun moving across the sky, build calendars based on that, and not even know that Earth goes around the sun. You can make all manner of measurements and not know what's causing it. We measure this thing we're calling dark matter. We measure this phenomenon, dark energy, that's forcing the universe to accelerate.
Scientists still do not understand the origins of the universe, including what caused the Big Bang and what happened in the moments after. This question is one of the most fundamental and profound mysteries in astrophysics. The Big Bang theory is currently the most widely accepted theory of how the universe began. According to this theory, the universe began as a singularity, a point in space and time where all matter and energy were compressed into an infinitely small and dense point. This point then rapidly expanded, creating the universe as we know it today. However, the Big Bang theory still has many unanswered questions. For example, what caused the singularity to exist in the first place? And what happened in the moments after the Big Bang, such as the period of cosmic inflation? Scientists are still working to understand the origins of the universe through a variety of experiments and observations. For example, the European Space Agency's Planck satellite has collected data on the cosmic microwave background radiation, which is the afterglow of the Big Bang. This data has provided scientists with new insights into the early universe and the conditions that existed shortly after the Big Bang. Black holes are objects with such strong gravitational force that nothing can escape them, not even light. Scientists still don't fully understand the physics of black holes, such as what happens inside them. This makes black holes one of the most fascinating and mysterious objects in the universe. The concept of a black hole was first proposed by Albert Einstein's theory of general relativity. According to this theory, the gravitational force of an object is proportional to its mass and the distance between objects. When a massive object like a star runs out of fuel and collapses in on itself, its gravity becomes so strong that it creates a region of space from which nothing can escape. This is the event horizon of a black hole. While scientists can observe the effects of black holes on their surroundings, such as the way they distort the paths of stars and other objects, they still do not fully understand what happens inside black holes. Some theories suggest that black holes could contain a singularity, much like the one that existed at the beginning of the universe. Others suggest that black holes could lead to new areas of physics, such as quantum mechanics and the theory of everything. Time is a fundamental aspect of the universe, but scientists still don't fully understand its nature, including why it only flows in one direction. This makes time one of the most profound and mysterious concepts in the universe. According to the theory of relativity, time is not a fixed entity, but rather a relative one that can be influenced by gravity and motion. However, scientists still do not fully understand why time behaves the way it does, including why it appears to only move in one direction, from the past to the present and into the future. One of the most intriguing questions about time is whether it could be possible to travel backwards in time. While this concept is often explored in science fiction, scientists still do not fully understand whether it is possible or what the consequences of time travel would be. And that concludes our exploration of the mysteries of the universe. From the origins of the cosmos to the nature of time, we have delved into some of the most profound and fascinating questions in astrophysics. While we have made great strides in our understanding of the universe, there is still so much left to discover. As we continue to explore and uncover the secrets of the universe, let us never lose our sense of wonder and curiosity about the vast and mysterious cosmos that surrounds us.